Okay, let's carry on. Page 92. And I don't know why it's taking me so long to figure out that I can minimize this guy, but he's gone. Yay. It's nuts. Okay, let's look at the next set of points. And I've gone ahead and done the graphing, and hopefully you guys have too. I want to, first of all, look and decide whether this is linear, and I can see from the graph that it is. And I want to take a look at the rate of change for the y's. The x's are going up by 1, which has been the case in a lot of our graphs so far. The y's are decreasing by 2. So for each x that changes, y is decreasing by 2. And we're going to use that information when we go to write our equation. But we do notice that this is a constant rate of change. So that's good. It's a linear function, and our words, to describe it in words, we're using the same instructions as page 91. As x increases by 1, y decreases by 2. That's our pattern that we're going to put into an equation, but that's our pattern in words. So what's left is to write the equation. So again, I start with y equals, and I notice what is y when there are no x's at all. When there's 0 x's, y is 8. That's where I'm starting. And now my change, my constant rate of change is coming. And our constant rate of change is going to be a negative, because for every 1 that x increases, y is actually going down by 2. So for every x, y is going down by 2. And again, you can plug in these values in your table and convince yourself that this really is the right equation. When x is 1, I get 8 minus 2 times 1, and that gives me 6. When x is 2, when x moves to 2, I plug in 2, and I get 8 minus 4, and on and on and on. So this is the equation of the line. We started with the constant, and then we added the pattern, just like we did on the example on page 91, example 2a. All right, let's look at another one. I haven't graphed this one yet. Oh dear. All right, 1, 2, 3. I notice that's fine for my x-axis. My y-axis only uses 1 point. 1, 2, 3, 4, 5. So there it is, right there. And my table says every single point for x is 5. So this is going to give you a horizontal line that's going to go on ultimately forever. And we ask ourselves, is this a linear function? Well, it forms a straight line. Is the rate of change constant? Well, yeah, it is, because the rate of change is 0. From every y to the next y, there is no change. So this is considered a constant rate of change. It's kind of a special condition because it's a perfectly horizontal line, but it still has the same properties of the other graphs. So the words, as x increases by 1, y does not change, or y stays the same. And finally, our equation. So the equation, when there are 0 x's, is y is equal to 5. And then as we move on up, we aren't changing at all. So when x increases by 1, we change by 0. When x increases by 2, we change by 0. So in following this pattern, the equation of the line simply becomes y equals 5. No matter what your x is, you're not changing, you're not multiplying it times any rate of change. So y equals 5 is the equation. Y equals 5 forever, ever, ever, no matter what the x. Okay, let's see. How long are we doing here? Okay. Let me go down and do one more. Just stick with me for a couple more minutes, and we'll get this page done. So if you go ahead and you plot these points, you end up, I think, with that one right there. Let's see, -2, -4. I'll try to do this real quick. -1, -1, 1, 5. And it's kind of going up pretty steeply. 6, 7, 8, about right there. I'm probably never going to be able to draw a straight line here, but it is a straight line if you have a straight edge, and I would suggest you always have a straight edge when you're graphing these. You can see that it is a linear function, and we need to write an equation, a function rule, and we're going to write it in words, and we're going to write it as an equation. So I'm going to let you guys set up your own table here, because all you have to do is copy the ordered pairs in this fashion. I'll do a couple of them so that you can begin to see the pattern. This is pretty much the way I look for the pattern. It's hard for me to see it just listed as ordered pairs. I like to see it in table form. So if I'm looking for the rate of change from here to here, I'm adding 3. And from here to here, I'm adding 3. And I'm adding 3. And I'm adding 3. So it's pretty easy to see that the rate of change, as x changes, as x goes up by 1, y goes up by 3. So when we're writing our equation, I ask myself, where is it when x is 0, when there are no x's? When there are no x's, y is at 2. And now I'm going to add the pattern. I'm going to add the rate of change. And it is changing in the positive direction, and it's changing by 3 units for every 1 unit of x. So that, my friends, is the equation. And you can prove this to yourself by plugging in your points, making sure that if you put in your input values, you'll get the correct output values that are listed on this chart. Okay, thanks for watching. We're done with this video.